For problem number 10, we're going to again use those limit laws. And so, but 10 is a little bit different. Let me write it down here for you. We have the limit as x approaches 2 of some function, which will be x squared plus 3x minus 10 over x plus 2. Now this is a rational function here. And so what we should go ahead and check is to see, one, does this simplify, and two, is that going to be an issue with the variable that we're approaching. Now, for this particular problem, we would have an issue if x was approaching -2, because if that was the case, that would make this denominator 0, and we couldn't use our limit laws as they're written. We'd have to use the variation of it, right? We'd have to look at a function that's similar, a replacement rule, which is on page 60. But this one's all right. So what we're going to do is we're going to take a look at the denominator of this, and we're going to say, okay, if we plug in 2, well, first we know x plus 2 is continuous. It's a linear function, right? So since x plus 2 is continuous, then the limit as x approaches 2 of x plus 2, that is equal to 2 plus 2, or 4, meaning that we can take this value and plug it in. You can only plug it in if it's continuous. If it's not continuous, then you have an issue. Okay? So this guy's continuous. Now what we'll do is we'll check the top. Well, the top is clearly continuous because we know that polynomials themselves are continuous. So x squared plus 3x minus 10, that's a quadratic function, qualifies as a polynomial, and so this is also continuous. Now once we've verified, so this is part of your solution, once we've verified that these two guys are continuous, well, then we know that the limit as x approaches 2 of the following, x squared plus 3x minus 10, we know that that's going to be equal to 2 squared plus 3 times 2 minus 10. Now don't get fooled here. Don't have too much confidence in this. So again, this is going to be 0 here. Now that's all right. If the numerator is 0, we can still find the limit. If the denominator is 0, we have an issue. Okay, and then we have to use the replacement rule. So first thing we check for is, are both of the functions continuous? Okay, this meaning, when I say both of them, I mean if the numerator was a function, the denominator was a separate function, are those both continuous? And these are. Okay. Now since they're both continuous, we can apply those limits properties on page 60. Okay, so again, I go back to page 60, and here's what I'm going to use. I'm going to use the product and the reciprocal rule. So the product and the reciprocal rule. Now what does that say? Well, that says that the limits as x approaches 2 of x squared plus 3x minus 10 over x plus 2, that's going to be equal to the limits as x approaches 2 of x squared plus 3x plus 10 times the limits as x approaches 2 of 1 over x plus 2. This is the product rule, so that I can split those guys up. This right here, I'm going to do the limit as x approaches 2 of x squared plus 3x plus 10 times 1 over the limit as x approaches 2 of x plus 2. Do you need to have all this written down? Yeah, you better believe you do. Okay. The only way to justify that you actually can do the limit is to use those limit properties on page 60. Okay. So what we've shown here is we know that the numerator and the denominator are both continuous functions. I've established that. I need to say that. If I don't say it, I can't use the property. Okay. Then I use the product rule. So this is the product rule. And then this, to go from here to here, that's going to be the, that's going to be the quotient, well, the reciprocal rule, or you can think about it as a quotient rule. Now, we'll just apply those. This is going to be the 2 squared plus 3 times 2. Oops. Let's see here. Is it plus 10 or minus 10? Let's go back up and look. It's minus 10, so I wrote this part down wrong right here. Not a big deal. We'll just get rid of that. There we go. And we got to multiply that by 1 over 2 plus 2. So this is going to be 0 times 1 over 4. And that's 0. So what I want you to notice again is this is my entire solution. This whole thing right here. From top all the way down to the bottom. That's what I'm looking for. That's what I want to see. If you don't do all that, you won't get all the points.